the universal wave equation. So I would not write this just yet on your formula sheet, but you will eventually put it on here. But the universal wave equation is V is equal to F lambda. Okay? If I just write this here and you just write it down on your green sheet, and I give you a whole bunch of questions on it, you might not be able to figure it all out because you don't know what these mean, okay? So that's why it's important to utilize your formula sheet. What I would do if I had it is I would write in small writing after it, I would write what these things mean. So in this case, the V here, the V is equal to the speed of the wave, okay? I would write this down somewhere, whether it's on your green sheet or just on a piece of loose leaf. So something to note is that in a lot of the questions they ask you about the universal wave equation, they will use the word speed and velocity sometimes interchangeably. They're not interchangeable, okay? There is a difference. I think we talked about it. Do we know the difference between speed and velocity?
There's one like with the weight of
Velocity is changing, isn't it?
Velocity has direction. So speed just says you're going 30 kilometers an hour.
But it doesn't tell you.
That'd be speed, but it doesn't tell you which way. So I could be going, I'm going like 20 kilometers an hour, or 5 kilometers an hour right here, going back and forth.
20 kilometers an
But
hour. You're
I really didn't go anywhere. I ended right here in the same spot. So my velocity would be
Is
0, while my speed was 5 kilometers an hour, okay? So all the velocity has is it has direction. And we would say it, we'd go like this. That's the only difference between speed and velocity. Nice little tick up there. But let's not worry about velocity right now. Let's just worry about speed. V is the speed of the wave. Just know that sometimes in the questions they'll say velocity, but it's talking about speed. Okay? Next thing is we've got this funny little F. What's the funny little F mean again?
Frequency.
Frequency, yes. Funny little F is the frequency of the wave. And lastly, we have lambda.
Which is
And what does lambda represent?
wavelength.
Lambda is the wavelength. Awesome.
Go to your nerd.
I pay attention in class. Like,
Oh, I'm not sure this is a good idea. I'm not sure. Sorry. You two are not gonna.
Hey, we'll get good.
Tanner got bored. Tanner
At
needed
least
a
he has a
friend.
desk now.
So, does everybody have this down? Or
Just wait for the
we're gonna do some equations. And I'll just leave it over here for you.
Frequency times the wavelength equals the
Funny
speed.
space.
yes, that makes sense.
This is another one that eventually I'll get you to add up there. Is these two, with period and frequency, or just one of them. But for right now, let's look at an example. I think I wrote one down here in my book. So let's say that a sound, say sound has a frequency of 262 hertz.
Wait,
And it has a wavelength of 1.29 meters. What is the speed? You want to try this one on your own or do it as a class first?
Try it out.
Try it on your own?
Very first
Okay.
step is always.
We'll do it, I'll give you 1 minute to do it, and then we'll do it on the board together.
Is it 1.1?
262 and 1.29. Oh, sorry.
What is the units? What is the units of this?
What is the units?
Yeah, speed.
In speed?
Like the answer. Like
Do
is
you
it
want
just
kilometers
S
in that or meters an hour?
or like
Meters
Or do you want to go by waves a sec, like meters a second?
Meter per second.
Meters per second. Okay.
Yeah.
HZ means hertz, right?
What's that, sir?
HZ means hertz, right?
Yeah, HZ means hertz. Yeah.
what?
I was saying that's what
Your calculator does some weird stuff.
we have the same calculator.
I know, but it was like a fraction at this. Your
Yeah,
first
and I
answer.
shifted it. I just pressed the shift. My calculator is just smarter than yours.
I don't think so.
Awesome. Okay, we're gonna go over this one together now. So, first thing you should do when you're doing a physics equation is read the question, and what I like to do is underline what I'm given, and then write down what I'm looking for. So I look at the question here, I see, hey, okay, I'm given my frequency here in hertz, I'm given my wavelength in meters, I've got the right units on both of them, and I'm looking for speed. So what I'll write down here is just V, question mark. What is V? That's what we're looking for, the speed. Okay? Then we'll grab my equation. We have frequency times wavelength. And I've got both my numbers there already. I don't need to change the equation at all. It's perfect for me. So I just go V is equal to 262 hertz multiplied by 1.29 meters. And I'll get my answer. So who was able to calculate that? Tamia? You said 337.98. 98 what? Meters per second. Awesome. So something I really want to emphasize is keeping our units in here. Because the numbers in physics really don't mean anything without the units there, okay? And a lot of the time they'll help us to understand what's going on throughout the question. I'm going to take Dane's question first, then I'll get to you, Chetner. Stay for 1 minute. We're going to do one more example. Then once you're free, you can go.
This is the
okay?
universal wave
Tanner.
equation, right?
If-
This is the universal wave equation.
Are we allowed to round in this?
Are you allowed to round?
Like 337.98. It's pretty close to 300.
What I'm going to say is, I'm not going to get into sig figs. Let's just say keep 1 or 2 decimal places. That's my advice. Okay? Keep them all the way throughout, and then keep 1 or 2 at the end. Yeah, we'll talk about that for later. I'm just gonna leave it for now.
Sig figs would make life easier for that, but in the end, trying to explain it was just.
Yeah. Okay, so we're gonna take a look at one more example. Here. I'm gonna say a sound wave has a speed of, what's a good number?
Are you going hertz per second right now?
29.3 meters per second.
Oh, he's driving. He moving.
I don't know, I just.
That's a good
Actually, no, he's not moving.
No,
I sound,
really
actually,
slow.
sound waves move a lot faster than that, but that's okay. I forgot I said sound.
I
We'll
didn't
just
know
say
it was
a
a sound wave.
An ocean wave.
You just said what's a good number?
I know, yeah. An ocean wave. Let's say.
No,
Okay,
but
that is a good number. An ocean wave has a speed of 29.3 meters per second. It has a wavelength. The wave has a wavelength.
My wavelength symbol looks so bad. I just look a line of
Of, let's say, this is going to be a big wave, hey? 4 meters? 4.75 meters. That's a nice big wave.
So you're just gonna make the hertz really small here.
Maybe. What is the frequency. I'll let you start this one on your own. We'll do the same thing. We'll come together and solve it as a class. Yes, Cardinal?
Here, I'll come join you here.
What are you looking at there?
Oh, I need to figure out the frequency.
We can try to figure out.
The hertz thing?
It gives us the hertz.
No, it doesn't.
Hertz is the frequency.
Oh, some right?
Yes. I found it, see?
I didn't round. Because he told me not to.
So we'll be.
So, but it's still separate.
We have a quick rule over this favorite area. There are
Share your answers.
we always cheat our tests.
You cheat.
When's football start?
No football.
Really?
Spring. I think no football. Not spring football. It's like, it'll be hot as balls.
That's okay.
Yeah.
That is okay.
It'll be nice for the second sem instead of having a lot of standing around to do.
Okay, it looks like most people
No, no, no,
are.
no.
Okay, I'll give you another minute.
I
just
saw
need
that
I
to
play.
please, like,
I'm not playing
Okay.
DB. If I play DB, I'm not playing.
You are gonna be DB.
I don't want to be DB.
I saw that play
I think I
against
did
Austin.
He was
Just
in
isolating
slow.
her.
That was a disgusting play. That was some like asinine shit. You were in cowboy. You were in jeans too. You could show Mr. Morrow a few things.
Give me a thumbs up when you're all good to go, please.
He did use it, so we just didn't acknowledge it.
What's the, for frequency, what's the unit of measurement?
Hertz.
And we can round it up to 2 decimals, please.
Yeah, absolutely. Okay, let's look at this one all together again. So we've got an ocean wave has a speed of 29.3 meters per second. Feels pretty fast. We've got 29.3 meters per second as our speed. Okay.
Good to know.
We also know that our wavelength is 4.75 meters, and we know we're looking for the frequency.
Moving pretty fast.
Awesome. So what I'll do is I'll put a question mark here by frequency, and I'll write down both my speed and my wavelength. So speed is equal to 29.3 meters per second, and my wavelength is 4.75 meters. Now, how can I use this equation? How can I isolate my frequency to solve? Yeah? Awesome.
That is pretty fast for an ocean wave.
Yeah. So what Tamia did was she took this equation. I'm gonna put it in black here, if I can find her a blue. So Tamia took this equation. V is equal to frequency wavelength, and she just put her numbers in right there, and then she solved everything. Okay. That's a great way to do it. What I think might be a simpler way to look at it is to do what we did right before. Just like switching them over. If that's your way to do it though, Tamia, keep doing it that way, because that works. I used to do it that way too. But, so what I would do here is I would solve for frequency. So, I know that dividing by lambda on both sides will give me my frequency alone. So I can cross these out, and I'll be left with
I guess it's second.
frequency is equal to V speed over lambda wavelength. Okay? Then all I have to do is just plug in my numbers. So I'll go over here. We'll say frequency is equal to speed 29.3 per second over lambda 4.75 meters.
That looks right.
Okay, and what do we end up getting? Mia, what was your answer? 6.16. Okay, did everybody else get that?
Yeah.
6.16, so our frequency is equal to 6.16 what? Hertz, right? Make sure you put that hertz in there or the answer doesn't mean anything, right? Really, really emphasize those units.
You could put the hertz in there for us when you're marking it.
What's that?
You could put the hertz in there for us.
When I'm marking it? Yeah, I don't think you'll like that. How do we feel with that one? Felt good? Okay.
Gee.
I'm gonna hand out the sheet. If we want to do another one on the board, we can.
So what's this backside?
Oh yeah, sorry. Yeah, we'll do the backside stuff, and then I've got a more advanced one here as well. But let's start with the stuff on the backside of that sheet.